Hi kids, in this video we'll continue with numericals from upthrust in fluid, Archimedes principle and flotation. This is from Conscience Physics exercise 5b. We have already done till sum number 8. You can click on the I button or see the description box. Let us start from sum number 9. What they have told. A body of mass 70 kg, when completely immersed in water displaces 20,000 centimeter cube of water. Volume of water displaced, when it is completely immersed in water is 20,000 centimeter cube. Find the weight of the body in water. Weight in water they are asking. Number 2, its relative density. The relative density of the material of the body. Relative density. Now look carefully. This much volume of water is displaced. Means this is also the volume of the body. No doubt in that. Yes or no? How much water it displaces? Now, when a body is completely immersed in water, what happens? The weight of the body acts downward and upthrust FB acts vertically upward, due to which there is a loss in weight. What is upthrust? V rho G. V is the volume, rho is the density of the liquid in which it is kept, into G. Now, volume is what? 20,000. So, we'll convert to meter cube. So, how do you convert to meter cube? From centimeter cube to meter cube, you divide by 6 zeros. How many? 1, 2, 3, 4, 5, 6. Because 100 3 times, centimeter to meter, you divide by 100. So, centimeter cube. So, 100 3 times. 1, 2, 3, 4. 1, 2, 3, 4. 2 1 times, 250 times. That's 1 by 50 meter cube. So 1 by 50. Okay. The density of water in SI unit is 1000. Isn't it? 1000 kg per meter cube in SI unit. G as it is. So this is how much? 20. 5 1 times 5. 20 G, which means 20. We can write this as 20 kgf. Yes or no? Done. So this is the upthrust. Now mass is 70 kg. So the weight of the body we can say 70 kgf. Yes or no? Weight in air is 70 kgf. Upthrust is 20 kgf. So how much is the weight in water? Weight in air minus upthrust, that is 50 kgf. So it weighs 50 kgf in water. Done. First part. Relative density. We know how to calculate relative density. Relative density is equal to, just use the formula, weight in air by weight in air minus weight in water. Done. So weight in air is 70 and this is 70 minus 50, that's 70 by 20. That's how much? 3.5, and that's a number. It does not have a unit. Just use a formula. Relative density is W1 by W1 minus W2, where W1 is the weight of the substance or the body in air and W2 is the weight in water. Done. Chalo. Now we look at the next sum. Now look at number 10. Very easy. A solid weighs 120 gram force in air. So weight in air, suppose W1 is 120 GF. And 105 GF when it is completely immersed in water. So W2 in water, the weight is 105 gram force. Calculate the relative density of the solid. Just now we did relative density of the solid will be W1 by W1 minus W2. Just W1 is the weight in air, W2 is the weight in water. So that's 120 by 120 minus 105, that's 120 by 15, that is equal to 8. Done. And it does not have a unit. Relative density is a pure number. It does not have a unit because it's a ratio. Okay, this was easy. Just use the formula. Now let us look at number 11. Now look at number 11. Very interesting. A solid weighs 32 gram force in air and 28.8 gf in water. So weight in air is 32 gram force. Weight W2 in water is 28.8 gram force. What they are asking? Number 1, the volume of the solid. Number 2, the relative density of the solid. Okay. Number 3, the weight of the solid in the liquid. Weight W3 in the liquid whose density of the liquid is given to you, in which they want the weight 0.9 gram per centimeter cube. Very easy. They have given weight in air, they have given weight in water, and they have given the density of the liquid in which they need the weight. They need the volume, relative density of solid. First thing, see, loss in weight in water is how much? 32 minus 28.8. Yes or no? That's the loss in weight. Weight in air minus weight in water. That is how much? 32. So 3.2 gram force. And this is nothing but upthrust. So we can say that upthrust is what? V rho G. V rho G is equal to 3.2 gram force. Yes or no? Now density of water, this is water. Density of water is 1 in CGS unit. So V into 1 into G is equal to 3.2 gram force, which means we can say volume is 3.2 centimeter cube. Done? Yes or no? So volume is 3.2 centimeter cube. Done. Relative density. Just now we did. Relative density is weight in air by weight in air minus weight in water. So that's how much? 32 by 32 minus 28.8. That's 32 by 3.2. That's 10. Which means the relative density of the solid is 10. Yes or no? Now look at the third part. They need the weight of the body in the liquid whose density is given at 0.9 gram per centimeter cube. Now, the relative density of the liquid will be equal to 0.9 because relative density is equal to the numerical value, of the density in CGS unit. Remember that. So the numerical value without unit is 0.9. So the relative density will be 0.9. Done. Now we know relative density of the liquid is given by weight in air minus weight in liquid by weight in air minus weight in water. Done? Just put the value. So this is 0.9 is equal to W1 is 32 weight in the liquid, suppose X, by 32 minus 28.8. Am I correct? Yeah. So 0.9 equals to 32 minus X by, this is 3.2. Yes or no? Yeah. So this goes over here. So 3.2 multiplied by 0.9. 9 2s are 18. Yeah, 2.88. So 2.88 equals to 32 minus X. So X is 32 minus 2.88. So X is how much? 32 2 minus 2.88, that is how much? 29.12 gram force. Now that is the weight in that liquid. Let me just check the answer. 3.2 centimeter cube, 10 and 29.12 gram force. Yeah, that's done. Now let us look at the next one. Now look at sum number 12. What they've told. A body weighs 20 gram force in air and 18 gram force in water. Calculate relative density of the material of a body. Very easy. Weight in air, suppose W1 is how much? 20 gram force. Weight in water, W2 is how much? It loses some weight due to upthrust. Is this? Relative density, we know the relative density will be W1 by W1 minus W2. Weight in air by loss in weight in water. So relative density is W1 is how much? 20 by 20 minus 18, that's 20 by 2. So relative density is 10. No unit, okay? Done? Yeah, that's the answer number 12. 10 is the answer. Now let us look at number 13. We'll do it over here only. 13. Just check out. A solid weighs 1.5 kgf in air. So weight in air is 1.5 kgf and 0.9 kgf in a liquid. W2 in the liquid is 0.9 kgf. Okay. Of density, the density of the liquid is given. Density of the rho of the liquid is given as 1.2 multiplied by 10 to the power 3 kg per meter cube. Calculate relative density of solid. Relative density of solid. Done. First of all, we'll calculate the relative density of the liquid. Now the relative density of the liquid will be density of the liquid, that is 1.2 into 10 to the power 3 kg per meter cube, but divided by density of water in SI unit, that is how much? 1000. Yes or no? That's your relative density of the liquid. So that's 1.2. So the relative density of the liquid is 1.2. Done? Now, we had a formula, remember? Relative density of the body is weight in air by loss of weight in the liquid multiplied by relative density of the liquid. I've explained all these, in the previous lesson. So weight in air is how much? Weight in air is 1.5. Loss of weight will be 1.5 minus this, W1 minus W2. 1.5 minus 0.9, that's 0.6. That's 0.6 multiplies by RD. RD is 1.2. Yes or no? RD of the liquid. Just simplify this. So 1.5 by 6 into 12.6 one time, 6 two time. Just do the calculation. That's 3. So the relative density of the body will be 3. Let me check the answer. Yeah, the relative density of the body is solid is 3. That remember the formula. Okay, and I've explained all these things in the previous lesson. Just go through it. Okay. Now let us look at number 14. Now look at number 14. What they've told us. A jeweler claims that he makes ornament of pure gold of relative density 19.3. He claims that the gold which he's selling is pure and the relative density is 19.3. He claims that, okay. He sells a bangle weighing 25.2 gram force to a person. The clever customer weighs the bangle when immersed in water and find that it weighs 23.075 gram force in water. Very clever, because you can find the relative density. What they've given, what they've asked, first of all, with the help of suitable calculation, find out whether the ornament is made of pure gold or not. Look, weight in air is given as 25.25 gram force. Weight in water is given as 23.075 gram force. Now with these two information, we can get the relative density of the gold. If that comes equal to 19.3, then it is pure as stated by the jeweler. Yes or no? So with these two information, can I find the relative density? Yes. Weight in air by weight in air minus weight in water, that is 25.25 by, this is 25.250, 23.075. So 5, 7, this is 14, 7, 1. Okay, this is 2.175. 2.175. Am I clear? Now 25, suppose, divided by 2 will be giving 12 point something, which means no, when you solve this you won't get this. That is simple. Am I clear or not? This is not equal to 19.3, which means it's impure. The gold which he claims to be pure is not pure. Now look at number 15. A piece of iron weighs 44.5 gram force in air. So weight in air is given as 44.5 gram force. If the density of iron is 8.9 multiplied by 10 to the power 3 kg per meter cube, find the weight of the iron piece when immersed in water. Weight in water they are asking, and density of iron Fe is given as 8.9 into 10 to the power 3 kg per meter cube. Now look carefully. We'll use relative density concept. Now, first of all, relative density will be density of the iron in SI unit divided by 1000. We know it. We have already done this, okay? This cancels out, which means 8.9. That's the relative density. See, when the relative density is in CGS, when the density is in CGS unit, then the numerical value becomes the relative density. But when it is in SI unit, you divide by 1000. Now, relative density is equal to weight in air by weight in air minus weight in water. We know this concept. Just substitute the value. That's 8.9 is equal to 44.5 by 44.5 minus x. Suppose x is the weight in water. Now we need to simplify. Just solve it. So 8.9 multiplied by 44.5 minus x equals to 44.5. Am I clear? So this 44.5 minus x equals to 44.5. This 8.9 comes over here. So this goes away. 8 5s are 5 9s are 45. 5 times, which means 44.5 minus 5 equals to x. So x is 39.5 gram force. So the weight, you just need to know this concept. Once you know this, put the value, get the answer. Weight in water will be 39.5 gram force. Yeah, that's the answer. Weight. So they are asking the mass. What they are asking? Find the weight of iron piece when immersed in water. They've given 39.5 gram. That's the mass. The weight will be 39.5 gram force. Done? Sure. Now let us look at number 16. Now look at 16, what they have told. A piece of stone of mass 15.1 gram is first immersed in a liquid and it weighs 10.9 gram force. Then on immersing the piece of stone in water, it weighs 9.7 gram force. Calculate. There are 4 things. First of all, mass is given. I'm writing the information. 15.1 gram. Weight in liquid. W2 because W1 I'll take weight in air. Weight in air is what? 15.1 gram force. No doubt. So weight in the liquid is 10.9 gram force. And weight in water, W3, is 9.7 gram force. Done? First thing, calculate the weight of the body in air. Weight of the piece of stone in air. That we have already calculated. 15.1 gram force. The mass is 15.1 gram. We can say that the weight is 15.1 gram force. Done. Number 2. The volume of the piece of stone. Now look carefully. Loss in weight in water. That will be this minus this, which is upthrust. Upthrust is what? V rho of the liquid into G, and that is loss in weight 15.1 minus 9.7. So V rho is 1 into G. This is how much? This is 5.4 gram force. So we can say volume is 5.4. See over here, gram force G. I'm not putting the value of G over here, okay? So 5.4 centimeter cube. Done? Yes or no? Now number 3. Part 3, what they've asked. The relative density of stone. Now we know relative density of the stone will be weight in air by weight in air minus weight in water. That is 15.1. This is 5.4. When you solve it, it will be 2 point something. 2 point. They've given 2.8. Solve it, you'll get this only. 2.8. The last thing. The relative density of the liquid. Now we know, we had a formula. Relative density of the liquid will be weight in air. This is of the liquid. Minus weight in liquid by weight in air minus weight in water. Yes or no? Solve it. This is 15.1 minus weight in the liquid is 10.9. 15.1 minus 9.7. So 15.1 minus 10.9 gives you 4.2. So that's 4.2 by 5.4. Yes or no? Point goes away. So that's 42 by 54. 21, 27, 3 7s are, 3 9s are. That's 7 by 9. Yeah, keep it like this only. They're given in decimal 0.78. 0.78. 9 7s are 63. Yeah. So the relative density of the liquid is 0.78. Just you should know all the relations properly, which we have already done. Then the sums becomes very easy. So this was the last part, last sum rather. We have section part C also, which we'll do in the coming videos. In this video, keep it till here and take care. And if you like the video, do subscribe and share.